The Engine Indication and Crew Alerting System, or Eicas, consolidates the display of engine parameters, crew alerting messages, and aircraft system status messages on two cathode ray tubes, or CRTs, for easy reference by the pilots. Eicas is designed primarily to provide engine displays on both CRTs. The primary engine displays appear on the upper CRT, and the secondary engine displays appear on the lower CRT. The specific engine parameters and operation of these individual displays is described in the Power Plant Indications module. In this module, we'll explore primarily the crew alerting feature of Eicas. Eicas also provides a means of alerting the crew of aircraft systems non-normal situations through the display of applicable warning, caution, or advisory messages on the upper CRT. Warning messages are red, while caution and advisory messages are amber. Warning and caution messages begin at the left margin, while advisory messages are always indented from the left margin. Finally, Eicas also provides status messages, which are displayed on the lower CRT. These white messages affect the dispatch of the aircraft, provide maintenance information, and will be described at the end of this module. Let's begin.
The system incorporates two computers, labeled left and right, two CRTs, upper and lower, a control panel, called Eicas Control Panel, and two push-button switches on the captain's side of the center instrument panel. The Eicas computers receive inputs from engine and system sensors and continuously monitor each other. If one computer fails, the other is there to instantaneously take over.
Now the computers display their information on the CRTs. The computer selector determines which computer is active and controls the Eicas CRTs. With the selector switch in auto, the left computer is in control. Should it fail, the right computer will automatically take over. When the left or right position is selected, only the corresponding computer has control of the CRTs. Now in this case, auto switching to a functioning computer, if the selected computer fails, is not available. The pilot needs to select the functional computer.
The bright knobs adjust the brightness of the CRTs. The outer control knob adjusts the brightness balance between the upper and lower Eicas displays. The inner knob adjusts the brightness of both displays. The event record switch is used to record systems data in Eicas memory for later retrieval on the ground. Only the last manual event recorded will be retained for future retrieval. Any previous data in memory is erased.
The engine and status display switches control the Eicas computers as follows. The engine switch selects the secondary engine parameters for display. Pushing the status switch causes the secondary engine display to disappear and the status page to be displayed. The thrust reference set selector, along with the max indication reset button, will be explained in the Engines module. In addition to the controls on the Eicas display select panel, two switches, a caution cancel switch and a caution recall switch, located on the captain's side of the center instrument panel, right next to the upper Eicas CRT, can be used to control the display of the caution and advisory messages. Warning messages are not affected by these switches.
On the glare shield, on both sides of the mode control panel, are two reset switches, which contain the Eicas Master Warning Lights and Eicas Master Caution Lights. Pushing either Master Warning Caution Reset switch extinguishes both Master Warning Lights and resets the lights for future warning alerts, except for landing configuration, autopilot disconnect, and takeoff configuration.
The crew alerting part of the Eicas system continuously monitors all aircraft systems. If a system fault occurs, a corresponding discrete fault light illuminates on the system panel, and Eicas displays a crew alerting message on the upper CRT. The more urgent alerting messages are also accompanied by oral signals and the master warning caution lights on the glare shield. The messages are divided into three categories: warnings, cautions, and advisories. Warning messages are the most urgent kind and indicate an aircraft system or operational condition which require immediate action. For example, a cabin altitude display constitutes a warning message. Caution messages indicate a less urgent situation which, nevertheless, require timely corrective action. A left engine overheat display is an example of a caution message. Advisory messages are the least urgent type. They require corrective action on a time-available basis, if any corrective action is even possible. A right yaw damper display is a typical advisory message.
Warning and caution messages are accompanied by ARL alerts. There are three types of warning ARL alerts: voice, bell, and siren. There are two types of caution ARL alerts: voice for the caution terrain alert and the caution beeper.
The bell indicates a fire warning. For example, a left engine fire message is accompanied by a bell. The siren sound, consisting of alternate high and low tones, will come on for warnings of cabin altitude, autopilot disconnect, overspeed, and configuration warnings. For example, a cabin altitude warning message causes the siren to activate. The beeper indicates an aircraft system abnormal. For example, a left engine overheat message causes the beeper to activate. The beeper consists of a signal which is made up of 4 beeps sounding in less than a second. The beeper sounds only once for an abnormal condition. Voice warnings are associated with wind shear warnings and ground proximity cautions. These are described in greater detail in the applicable CBT modules. Pushing the reset switch also silences the fire bell, the beeper, and the cabin altitude siren.
The autopilot disconnect siren has to be silenced through the control wheel autopilot disconnect switch.
Certain parts of the crew alerting system are inhibited during takeoff and initial climb. The beeper and the master caution lights are inhibited for all cautions between 80 knots on the takeoff roll and 20 seconds after nose gear strut extension or 400 feet radio altitude, whichever occurs first. Now, if the takeoff is aborted above 80 knots, the inhibit remains until the airplane slows to below 75 knots. Any caution existing when the inhibit is removed activates both master caution lights and the beeper. The fire bell and master warning lights are inhibited for fire warnings only from nose gear strut extension until 20 seconds after nose gear strut extension or 400 feet radio altitude, whichever occurs first. Any fire warning existing when the inhibit is removed activates both master warning lights and the fire bell.
When the fuel control switch is moved to cutoff, messages consolidate to left or right engine shutdown, as shown here.
The beeper and master caution lights are also inhibited for most cautions when the airplane is on the ground and both fuel control switches are in cutoff. For instance, a fire warning test of the engines will not activate the beeper and master caution lights for the engine overheat condition test, although the left and right engine overheat messages are displayed. Furthermore, when the engines are being started, new caution and advisory messages are inhibited until the engines reach idle RPM. For example, no oil pressure built up. However, the exceptions are the left and right engine starter and starter cutout messages. For example, if an engine start valve fails to open, the inhibit is canceled and the starter message is displayed. Some alert messages are briefly inhibited or delayed to allow a situation to correct itself before activating. For instance, during gear retraction, the gear light illuminates briefly, signaling a disagreement between the gear and the gear lever as the gear is in transit. However, the gear disagree message is delayed for 25 seconds to allow for normal gear retraction or extension times. A status cue appears in the upper left corner of the lower Eicas screen whenever a new status message is generated, but the status page is not currently displayed. Pushing the status button displays the status page on the lower Eicas screen. Status messages are displayed in white on the right side of the screen to indicate system faults that may affect the dispatch capability of the airplane. The messages are displayed in the order of occurrence, with the most recent message at the top of the list. Status messages may also be used in conjunction with an alert message and the system discrete light to determine a system's condition. For example, the APU won't start, and the APU fault advisory message is displayed in conjunction with the illuminated fault light on the APU panel. Consulting the status page in our example shows that the APU door, the air inlet door, did not open, which is preventing the APU to start. The status page may be in view for APU start. This allows the crew to monitor the APU starting progress rather than waiting until the run light illuminates.
The status page will be selected after engine start for flight control checks or any time to monitor hydraulic system pressure.
Brake temperature indications are also available on the status page. Brake temperature indications is described in greater detail during the landing gear and brake module. If an Eicas CRT fails, the failed CRT blanks. Engine indicating and crew alerting messages appear on the functional CRT in the compacted mode, and an Eicas display advisory message appears. A failure of the control panel generates a full-up engine display with the alert message of Eicas control panel. The cancel and recall switches are now inoperative. However, the brightness control and computer selection capability remain operational. Now, if both Eicas computers fail, the standby engine indicator is automatically activated. The standby engine indicator is described in the Power Plant Indicators module.
The oxygen system consists of quick dawning mask and regulators located at each flight crew and supernumerary seat. Portable oxygen cylinders are located in the flight deck area for emergency use. With the cylinder shutoff valve open, an oxygen bottle pressure transducer provides cylinder oxygen pressure information for display on the Eicas status page. The status page pressure indication will quickly decrease during testing of the mask if the shutoff valves are closed. The pressure-reducing regulator decreases cylinder pressure from 1850 psi to about 70 psi for use by the crew. The bottle pressure-reducing regulator also contains a relief valve that is connected to an overboard discharge port located immediately below the bottle in the side of the airplane. A green disc normally covers the port. The absence of the disc indicates a bottle discharge due to overpressure. Each of the cockpit oxygen masks is also outfitted with a diluter demand regulator. The pilot's mask, regulator, harness, and hoses are contained in a stowage box located outboard of each pilot's seat. The masks are designed to be quickly donned with only one hand. All controls are on the base of the unit, and a microphone is installed in the mask. An N100% switch on the mask allows selection of normal diluted oxygen or 100% oxygen when the pilot inhales. When the switch is pulled out to select normal, the delivered oxygen is diluted with ambient cabin air. This allows the bottle to last longer, but is not usually selected for dispatch. The switch is pressed in to select the 100% oxygen delivery. This mode is normally selected for dispatch. To test this system without pulling out the mask from the container, push the Reset Test Slide lever down in the direction of the arrow. During the test, oxygen under pressure is delivered to the mask in the stowage box. When oxygen flows to the mask, a yellow cross displays in the oxygen flow indicator on the upper right side of the mask container. The emergency test selector has two functions. It may be pressed to provide a mask test. Oxygen will flow into the mask and across the mask microphone when this knob is depressed. Or, the knob may be rotated clockwise to select the emergency mode. In this mode, 100% oxygen is delivered under pressure at any cabin altitude and regardless of the position of the 100% switch. The mask assembly is pulled out by grasping the red release levers. When the right lever is squeezed inward, oxygen flows to the mask harness, causing it to inflate for quick donning. The yellow cross appears while the harness inflates. When the mask is pulled out, the cover doors are opened and the mask oxygen flow begins. You should keep the release lever squeezed to keep the harness inflated until the mask is donned. When the release levers are released, the harness will deflate around the user's head. The elastic in the harness will maintain a tight fit around the user's head. The levers may be squeezed again at any time to reinflate the harness for mask removal or adjustment. After the mask is donned, the yellow cross in the oxygen flow indicator only appears when the pilot is inhaling, but will appear continuously when the emergency test selector is rotated to provide continuous pressure flow. The doors may be closed without interrupting the delivery of oxygen to the pilot. The oxygen may be shut off if desired when the doors are closed by pushing and releasing the Reset Test Slide lever. To initiate the flow of oxygen again, the pilot may open the left door of this stowage box. If the mask is removed from the pilot's head, the left door should remain open to allow oxygen pressure to be available to inflate the harness for donning when the release levers are squeezed. Pre-flight. Set up the audio selector panel to allow transmission from this mask microphone over the flight interphone to the cockpit speakers. Slide the Reset Test lever down to deliver oxygen to the mask regulator. Notice a momentary yellow cross to confirm oxygen flow into the mask and that the mask supply hose has no holes. Next, position the boom oxygen switch on the respective audio panel to oxygen and either push the audio control panel push-to-talk button or hold the respective pilot control wheel push-to-talk switch in the mic position. Now press the emergency test knob to cause oxygen to flow across the mask microphone. If the mask microphone is keyed for transmission, a hissing sound will be heard over the cockpit speakers. This completes the pre-flight test of this oxygen station. A passenger oxygen switch located on the overhead panel allows the capability to check the number 2 oxygen cylinder pressure. Pressing and holding the switch allows the flight crew to observe the oxygen pressure of the number 2 cylinder on the Eicas status display. The on light illuminates in the switch to indicate crew oxygen bottle number 2 is selected and can be viewed on Eicas.